welcome back to the channel. Today's video is for the HackerRank series with birthday chocolate exercise. This problem is regarding two kids, Lily and Ron. Lily wants to share her contiguous chocolate tablet with Ron, but under certain conditions. Let's check them out. So we have to create a function that receives an array with all the numbers in the chocolate squares designated S. In this example, S is an array with 1, 2, 3, 4, 5 chocolate squares with 5 numbers on each square. We will also have a variable called M that will stand for the month of Ron's birthday, and also, and more important, the number of squares that Lily is going to allow us to give him. Also, the total squares summed must be equal to the variable D, which is basically Ron's day of birthday. So let's dive deep in this awesome drawing of mine. So, in this first example, we've got two possible combinations. As you can see, you have 1 plus 2 that equals 3, our day of birthday variable. For the month of the birthday, it's February, which is month 2. And that means that we can only have 2 squares summed, 1 and 2, or 2 and 1, since in this example, in concrete, those are the only 2 options that we can return in our function. Essentially, for me, the great question behind this is how we transpose this to code. So, prior to run any line of code in HackerRank, we cannot know the length of our list, and we don't know the day or the month. So we basically must assume an array of squares. So in this case it's 5, but it can be 3, 2, 1. 1 is not an array, of course, but neither 2. But we can have 3, 4, 5, 6, 20, 100, several, as you can already understand. And since we don't know the M or D, or either the length of F, we have to work with the len of S. I guess this is pretty much easy. And we have to work with the positions of the squares, right? Because at the end of the day, we know that the number of squares to be summed are the M squares. So, for instance, in this case it's 2, so we have to sum arrays index position 0 with arrays index position 1, arrays index position 1 with arrays index position 2, and so on and so forth. Let's dive into HackerRank. Ooh, sorry. I was already trying some code. And so, as you probably might seen, and as I mentioned previously, we should begin with 4, right? To iterate over our list. So for a specific index in range that will be the len of our list. Does that make sense? And as we have seen previously, either on our last video with list slicing, or anyway, in some tutorial in the internet, Python has amazing functions in the lists. So we are certainly working with the list. And as I mentioned in my awesome drawing, we should be considering position. So for instance, if I have SI, I will have every single position in the list in every iteration. So first iteration will give me, for instance, 1, second iteration will give me 2, third iteration will give me 3, so on and so forth. So, but we actually need, and as you might seen previously, we need the first index and the second index. So how do we get the second index? I plus 1. In this case, we could get the second, but let's see. Yes, so in this case, M was 2, so we know that we need the first and the second, and the first and the second and the third, and so on and so forth. But what if we have 3? What if you have 4? What if you have 6 on M? You have to always be counting for that amount of index. So my advice for you is to put M here. So with whenever value M could get, you will always be counting for an interval of that length. And we have also spoken that we need to sum all their indexes, because Lily will give the sum of that squares if that squares match the D variable. So we have to sum them, and we can probably put in a variable like total chalk. Now this is total interval, okay, and total interval will be our variable. So, but we must verify if that variable is equal to this variable given by us in the function, because this is the amount of chocolate that Lily wants to give. And that being said, sorry, here. That being said, we are already verifying, so here we need to compare. If total variable equals D, we have to store that possible in a variable, that possibility in a variable. So total combinations plus equal 1, and this will be created here with 0. And last but not least, our function should return the total number of possibilities. Just checking, I'm almost 100% sure, but the number of ways that Lily can divide the chocolate bar. Yes, so we should return total combinations. Jesus Christ. It's a function return. Okay, let's run the code. Yay! Okay, so that's basically it, guys. I hope I was clear. If I was not clear, please leave a comment below. Tell me what didn't you understand. And I see you in the next video. Until then, happy coding. Bye.